All right, so in project 3, we're going to build our neural network that is going to predict whether or not a movie review has positive or negative sentiment by using the counts of words that are inside of our review. Now, the changes I made first was to create a preprocess the data function that just brings in all the kind of little snippets that we built and tested above. So, word to index, kind of the different vocabularies and vocabulary sizes, just all the variables that we used in our training dataset generation logic, I wanted to have in a pre-processing data function so that it's all kind of self-contained in the variables that are in this class. The next thing I did was I split off the stuff that was in here into an init network function just to keep things clean. And also this needs to know, the number of input nodes, number of output nodes, which is based on the number of reviews and unique view or unique vocabulary in our reviews and the number of labels that we have. So it's nice to kind of have these in separate functions just so that you can kind of read the progress that's here and just cleaner that way. I kind of like it. And the next thing I did was, update input layer and set target for label, which are these functions that we played with before. I went ahead and moved into the class just so that it's all kind of self-contained and together. And that makes this class portable so that I can use it somewhere else. All right, so now in the train method, this is where most of the action is, right? So the first thing I checked was that, the number of training reviews we have is the same as the number of labels. So in the off chance someone inputs something that doesn't line up correctly, we kind of want to let people know, or else we just get kind of weird behavior in the neural net. And the next thing we're going to do is kind of initialize a correct so far. We're going to keep track of how many predictions we get right and wrong while we're training. This is a useful metric that I kind of like to watch to understand how the neural net is doing during the training process, right? Is it getting better? Is it not getting better at all? Is it getting worse? These things are really kind of the basics of understanding how you're doing and then being able to adjust for that. Now, so we select a review and a label out of our training reviews. We update the input layer. This is the same as previously we were propagating from layer 0 to layer 1, or from your input layer to your hidden layer. However, in this case, we have to adjust and generate our input data set first before we can do this propagation. So now we generate a hidden layer same way as before, except without a nonlinearity. And the last one we generate with a nonlinearity. So that's our forward propagation step. Our back propagation step, the first thing we do, how close did we miss? So this is where we put our function that we created, and we say our prediction minus our function. And then because we have a nonlinearity on this layer, nonlinearity on this layer, our layer 2 delta has to multiply by this function, which is sigmoid times 1 minus sigmoid. And then we continue to backpropagate in this way. Now, the thing that you see we skip here is that because there's no nonlinearity on layer 1, we don't do this multiplication step here unlike before, because this is a linear layer. So we don't actually have to adjust for the slope of the nonlinearity. Once we have our layer 2 and layer 1 deltas, we're ready to update our weights, which you do here in the exact same way that we did in our previous neural network. And then I add a little bit of logic just to kind of log our progress, as well as see how fast we're training, and how many predictions we got correct. Now, how am I deciding whether we got something correct or not? What I'm looking at is the absolute value of our prediction. The actual value of the error of our prediction. So up here, we calculate the difference between what our prediction should be and what it was. And so I said, if it predicts exactly 0.5, well, it didn't, it's totally ambiguous. It's kind of halfway between positive and negative. It didn't pick either. But if it's closer to the right prediction, well, then this error measure will be less than 0.5. And so that's why I can kind of see how many classifications we got right as opposed to just the loss, by kind of just tabulating this on the fly and then logging it as we go. Now, the other thing we want to be able to do here is test it, which is really just a matter of kind of taking the forward logic and then the evaluation logic and putting that into one function, which I did here. And then I added another one for running, where we can put in a text review, and it converts that text into input data and just forward props and then gives us a positive negative label. So we can test it on the whole data set, or we can kind of just throw in some examples and see whether we like it. So now that we've got this, let's go ahead and first validate that first we create one, right? So here I'm actually selecting the first 24,000 reviews to train on, and I'm just going to go ahead and say that the last, let's say 1,000 reviews can be our test data set. So I'm going to kind of continue to do that. You could pick a different training test split. There's another 25,000 in the IMDb data set you could use, but just for the sake of making it easy, I think we're just going to go with this. So we're going to initialize it this way. This is actually our default learning rate from up here. I'm going to go ahead and put it in just so we can see it. The other thing I like to do before we get started is actually test it. So our weights are initialized randomly right now, so it shouldn't really predict well at all, right? So in this case, the testing accuracy is exactly 50%, which is, if you just guessed between positive and negative randomly, then in theory you should get 50% accuracy, and it's actually what we see here, which is a good place to start. Especially when you have a neural net with only 2 predictions, I really like to see it start off not being biased towards one way. Like if I initialize my weights in such a way where it always predicts one way or always predicts another, or it doesn't get any of them right, then I'm kind of scratching my head like, wait a minute, something's probably broken here. And so I'll go investigate that first. But so as we can see, it's predicting randomly, and it doesn't seem to have any real predictive power at the moment. So now we're going to try to train our network. Every something I threw in here a little bit later is that every 200 or 2,500 predictions, it'll do a new line, so we can not just see what the progress is now, but we can kind of see it change over time. So now when I'm watching it train, there's a few things I'm looking at. First, the speed. Trying to kind of gauge how long am I going to be sitting here. And then I'm also looking at the training accuracy. So now if you look, so far it's actually not predicting particularly well. It's doing just worse than random, which is sort of worse than it was doing before. At this point, when we're 14% the way through the training data set, and it hasn't even learned anything yet, and it's actually doing worse than that, I'm really starting to go, okay, something's probably wrong here. There are a few types of neural nets where at this point it actually does continue to predict random, especially in reinforcement learning. However, on this data set, we're looking for direct correlation. I should be seeing some change right here. So I'm gonna go ahead and quit this out. We could wait longer, but I just don't think that it's going to be a good idea to do that. So we're gonna go ahead and hit stop. The natural thing for me to do here is think, okay, so the learning rate's too high, right? So when things are doing like this, maybe it's diverging, who knows? So let's go ahead and adjust this learning rate to be lower. And a good way to kind of feel things out is first move by orders of magnitude. So I'm going to divide by 10, reinitialize the network, and I'm going to try training. I'm going to keep this last one around just so we can compare. Okay, bouncing around a little bit. Man, I'm starting to see kind of the same behavior. It's not really getting better. Now, I'm going to let this train for a second and kind of talk about why was I lowering the learning rate. So the learning rate, if you remember from before, is the step size. It's how big of a jump the neural net tries to take to reduce the error. Probably, a standard reason why this kind of thing happens is that it's overshooting, right? And so it's ending up not really any closer to solving the problem than when it started, because it's going too far. Undershooting means that the network trains very, very slowly, but it does tend to make progress. This, to me, it could be very, very slowly, but it just doesn't really look like it's training at all. It's just camping out right near 50%, and so that's really concerning. So we're at 20% here. I should be seeing something at this point. So we're going to cancel this, and we're going to go knock down the learning rate again. So let's check this out. Do it one more time. Okay, camping out, 40%, 48. Come on, buddy. It's funny. Eventually, these types of metrics become really entertaining to watch. And man, I'm actually still kind of surprised it is not really happening. Oh, here we go. Okay, so it's starting to learn a little bit. So this is a good sign, right? So it's starting to find correlation, but it's still going pretty slow. Not only, this is pretty slow, as far as reviews per second. It's only actually processing 100 reviews per second, but then it's not converging very quickly, right? I could keep knocking down the learning rate, but the truth is, the more you knock down the learning rate, the slower the learning happens, right? Whereas before we were overshooting, this is still going to continue knocking down. So one thing that I could do here is just continue to tweak the learning rate, and I could spend all day trying to do that, and I would get incremental improvements. But we're so early on, we haven't refined anything. There's probably some big frame questions that we need to really reevaluate in our neural network to say, hey, can we frame this problem so that the correlation is a little more clear, right? So right now I'm going back and I'm thinking, okay, so up here, this is our setup, right? We're counting the words, we're putting them in here, and then it's making a prediction. what about this is so difficult for this thing that it's taking this slow? I mean, so it is converging, but it's just not going very quickly. Is there anything that we can do to make it more obvious for the network that if we've identified the words that were validated in kind of our well, not those lists, those are the raw counts up here, right? So where it finds these words more easily. So there's two things that I typically do here. One is I start changing stuff and see if stuff works, and the other one is I dig deeper into exactly what's going on here. Take a look at a few training examples, see that, make sure that the pattern that I think should be in there is actually showing up, or maybe I have a mistake in my logic. 9 times out of 10, when something's not training correctly, it means that there's something really simple in here that I got backwards, more than a big complicated change. But sometimes it needs to be a big complicated change. Still training really, really quickly. So I mean, if we extrapolated this, things tend to train fast in the beginning and then slow down and taper off. So I mean, I don't really see this getting much past 61, 62, something in that kind of range, unless I keep training, right? So now I'm asking the question, okay, how can I make this simpler? What is the signal in my training data, and what is the noise in my training data? And that's going to be kind of the topic of the next section, which we're going to analyze and then try to see if we can get this train to happen faster. So feel free to let this kind of train all the way. I don't think it'll get too much past this, and I really feel that we're going to be able to build a better classifier here in a minute.